I have the project set up here. As you can see, this is the same project I demonstrated last week in the previous video, and it's using the restart. Alright, so here's the demonstration for deployment. I have opened the project. This is the same project that I demonstrated in the previous video in the last week. It's the donation dataset. It is using the BZAN9797 dataset. So assuming that I have trained my best model here, and the best model here turns out to be neural network, it's slightly better performing than the decision trees. So what do I do after I have compared the models and have chosen the best model? The best model will come out of this model comparison node. So I should follow the scoring node after the model comparison node. So here, let me zoom in to make it larger here. Now I am suppose that I'm ready to score the model. I need to create two things. I need to bring in a score dataset, and I need to use a score node. So first of all, the score dataset. A score dataset is a score data source that I need to import to the SAS project here before I can, before I can bring the node to the path, to the diagram. And so now I need to create another data source here. And you should, before you do this, you need to make sure that you have downloaded the score dataset, which is different from the train dataset. It doesn't have the target variable column in it. It doesn't even have the column. Not that it doesn't have the value of the target value. It doesn't even have the column. Here it doesn't have the donor or donation target variable column in it. So that's a score data source. So to create a data source, I can right click here, or I can do the file new. I'm going to right click data source and create new data source. And by the way, this demonstration follows the tutorial of the PDF tutorial, the one about scoring dataset that is shown on the screen. All right. So I'm going to magnify this one. I'm going to do this, and I discover that I can avoid, I can avoid distangling the item that I click from the item that's shown on the cursor. In the last video, there is a disconnection between them. Here, I discover how to avoid those situations. I need to bring the magnifier into the region where it's magnified to avoid that situation. Okay, so I will create a data source in the same way that I created a data source for the train. I need to look for the data. And here the data that you should look for is the score data set. And suppose that you have one. And now I'm using a fake PVA fake score data set. It is not exactly a true score data set, but it can fulfill the purpose here. So I would choose that. And I might have zoomed out of the region, so I have to redo this. Okay, magnify. Oh, it's too big. The table is too big. Okay, click. Okay, And let me redo this again. So next, I'm going to configure this table. And instead of going to the advanced, let me do it one by one. Use the basic. So here, for the score data set, I should not be able to see the target. You know, so in the real score data set, you won't have these target. So, you know, so here to imitate the score data set, I would have to reject the target B, which is a target variable. And also I will reject this because in the training set, I do not have, I also rejected the target B. By rejecting both of these variables, it is imitating a score data set where it's actually not exactly. Also, in configuring your score data set, you want to make sure that the rows and levels, besides the target variable, you want to make sure that the rows and levels are exactly the same as you did in the training set. So I'm going to skip this step because it's very tedious. But when doing the project, you want to make sure they have the same configuration. Otherwise, SAS will give you a problem in the process of the scoring. Okay, confirm the number of cases. And score data set tend to be small because this is a fake. This is exactly the training set actually, but I'm using it as a fake score set to demonstrate the process. Number of rows tend to be small in the score set. And it's a score set. This is very critical. You want to make sure that you change the row here. You want to make sure that you change the row here. Because it's a score set, you want to explicitly change it to score. Do not skip this step, otherwise you'll run into a problem. Okay, after that you confirm the levels and number of variables, levels, rows of data set of variables in the data set, and confirm. Now that you have a new score data set here, to score this data set, you want to drag that to the diagram, and you can put it parallel in vertical manner to your model comparison, because both of these nodes would need to feed into the next node, which is the score node. In the score node should be in utility. Score code export. Maybe it's in assess. It's in assess. So bring the score node into the diagram and rearrange the diagram. It's the score node that is used to apply the trained model, the best model that you select, on the score dataset. So you need to link the model comparison node and the score dataset together to the score node, and you can mostly okay, let's do this. You can mostly accept the defaults, the default setting of the score dataset, but it also allows you to specify some of the other options if you want. You know, if you do have a test set, you can choose to score the test set. I don't have a test set here. And you can choose to generate the SAS code of the entire score process and optimization process. Here I don't. You can turn off the reporting of the graphical of the results graph. I'm going to accept all the defaults here. So after that, you can run this to score. Now, because it's fake data set, because I didn't compare and make sure all the variable rows and levels are exactly the same, I may run into problem here. So don't be surprised when you see a problem, see an error in your score process. It indicates that there are something that you have to check and make sure those issues are cleared. It takes some time for the score process to complete. Oh, great. So the score process actually finished successfully. That means the score data, even though it's a fake score data set, the specifications of the variables are correct and the same as the training set. Now let's take a quick look at the results here. So let's do the magnifier here. Where is it? Okay. And target is a binary variable. And let's take a look at whether or not there is important outcomes here. Important results. Class variable summary. And I do see here that there is, so in addition to the classification, in terms of the label of the scoring, you have a positive or negative donor classification. Besides that, the model internally also produced a probability of the target. The prediction of the class or the classification of the label is based on the probability that a case is predicted to be a donor. So this probability column is it's a product of the model scoring process, and it is an interval variable. So it shows the the statistics of this variable. It does have a median of close to 50%, so half and half. Half of the cases were predicted to be donors and half non-donors. And whereas target B no is when the outcome is predicted to be a non-donor with a label of 0, and predicted to be a donor where the label is 1. So that's all the results here, not many important things. So, and let's also take a look at the exported data set here, and we should expect it to at least see 2 new columns. One is the probability of being a donor, and the other is the actual classified label of the case. So exported data set of the score node. So we look at the score, and let's browse. And all of these should be the input and as well as the imputed variables. And beginning here, these are the product of, or some byproduct of the scoring process. And the 2 columns actually have more than expected, because the target variable is a binary. Because the target variable is a binary variable, it has 2 different labels. So algorithm will output the likelihood of predicting both labels separately. But you know that the probability of 2 labels should add up to 1. So for the same case, the likelihood of predicting a label of 1 is smaller than 0.5, and it will be predicted to be a label of 0, which is non-donor. And the likelihood of predicting 0, 0.616, should should be 1 minus the likelihood of predicting the label of 1. So if you add them two together, it should be close to, it should be 1, and they conform the result. And if you go further to the right, you will see the prediction for the target here. And the prediction to the target, I said for the first case, it will predict a label of 0, which is non-donor. And here you also see the same 2 columns. So the target, so the scored data set, the output from the scored data set actually includes multiple columns of the results, but they are somewhat redundant here. Whenever the predicted probability is over 0.5, it will it will predict that the outcome is 1. But when the probability for the target is below 0.5, it will predict the outcome, the label as 0. So you can confirm these results. 1 whenever it's over 0.5, 0 whenever it's below 0.5. Okay, so the predicted columns are confirmed in the export data set of score. So now I'm ready to export the scored data set, which is different from the score data set. Score data set provides the inputs of the new cases, whereas scored data set will provide those inputs as well as the outcome, the predicted results of those cases. Now, as I said, there are 2 approaches. There's an approach with coding, and I will demonstrate that first. And afterwards, I'll demonstrate how to use a SAS node as an alternative to save the data, to save the scored data set. Now, to do the SAS code, you'll find under utility there's a SAS code, and bring that to the diagram and connect the score connects the score node to SAS code. And for SAS code, the only thing that you need to do is do a little bit programming, and you need to open this. This is called code editor. Click the ellipse. It will take a little bit time for it to come up, because it's trying to locate the function, a deep function in the SAS Enterprise Miner, the codes function, the interface to access the codes deep inside the software. So it takes a little bit time here. And now we have it. I need to bring the magnifier again. I always accidentally close it, so I always have to reopen it again. And here, the only thing you need to change is the training code here. So let me magnify this portion. So that's the training code. And I need to talk a little bit about the SAS syntax here. As you start typing, this is kind of a part of the IDE, integrated development environment. It will color code the different codes that the different keywords that you type in. The first line, as according to the page 7-14 of the PDF tutorial, it's a data statement, and followed by something dot something else. The portion before dot is the library, and because your library is different from what the tutorial on the PDF shows, so you should use your own library name. If you need to check the library, go out of this window and to check what your library is. I remember that my library name is mylib, so type mylib, and then the portion after the dot should not be altered. You should copy exactly, so type exactly the name of the exported score data. This portion should not be changed. I mean, the portion after the dot should not be changed. It's difficult to highlight the exact portion. Exported score data, and this is the keyword for the exported data of the score node. And don't forget this semicolon here. After that, go to the next line and type 2 spaces. The exact spaces don't matter. The indentation here is not mandatory, but it helps organize the codes. And the first line of code, what it does is it creates it created this new data set in SAS. The data statement is creating new data set. And the second line of code is to copy an existing data set. And for this existing data set, it's in the memory, it's not in the library. So you need to, you will type the exact same name of the dataset in the tutorial. It's EM Enterprise Miner underscore import score. It's the dataset behind the score code. And don't forget the semicolon. And then the last statement is run. So this will tell it to run the block of code. Okay, so that is it. Double check the names are correct. EM import score. And this is the data set that will be exported and will become the name of the data set that you will find in Windows Exploratory. Now I am ready to run. Before I close this window, I'll make sure that you save and close it. And now I am ready to run this the SAS code to export the dataset. After it runs successfully, I should be able to find a SAS data file in the library, in the folder that the library points to. My lib is pointing to a location under the place where I normally keep all the other SAS data sets and other projects. So, and it it does run successfully, so I'm going to open the File Explorer. No, File. Let me open it from my computer or this PC. I should be able to find under the D drive SAS Enterprise Miner, I should be able to find the exported scored data. EM exported scored data. EM exported scored data has a date of April 5th, 6 o'clock. It's right now. So confirm that this data set is the data set that's exported by using the SAS code. All these are not because they have a different time. Last year or more than 1 year, and because I'm going to use the other method to export the data set, I'm going to temporarily move these to another folder because they will have the similar names, and I don't want to overwrite all of these data files. So everything that starts from EM, I will move it to the new folder. And okay, now let's come back. And this is method 1. The alternative method is by using a save data node. So let me bring the save data node parallel to the SAS code. You understand that this is the alternative method of exporting data sets. All right, in configuring the save data node, let's do a few settings here. You can specify the library name, and in this case I'm going to specify the same library name here, and it's my lib. And alternatively, you can specify a direct path to any directory of your choice. You don't even have to have a library available there. Output data, which do you want to output all rows? Yes, it will output all the data set, including the train, validation, and score data set. Or you can specify a specific row of the data set, other than train. If I don't want train, I don't want validation, I don't have test set, so changing this will not matter. Transaction, I don't have transaction row of set, so changing this will not make any change. But score data set, I do want to export and save the score data set, so I confirm this is yes, while the other train, I don't even have the validation. Even though I have the validation partition, it's technically still under the train row of data source. So make sure you select no for train. Then anything other than the score data set will not be exported. And if I run this, I should expect to see an additional data set appearing in this same library. So let me sort by the date. This score data is the data that I exported previously by using the SAS code. And after the save data node successfully runs, I would expect to see an additional data set here, additional score data. There you go. The save. No, I thought I did not want. Okay. Even though there is no validate data set, it will output this one, and it I don't expect to see this, but it does. But anyway, I don't expect to use this. Let's see if it changes after it runs successfully. Alright, it runs, and let's check the data sets again. I do see 2 additional data sets, but only the score data is what I need. I can safely remove the validate data. So 2 ways to extract the scored data set here, and both ways are successful, and they should be the same, even though their size is different. If they may contain different numbers of the input variables, but you know what you really care is the prediction results. All right, I hope you enjoyed this video, and see you later.